Hi, we present Airbird, our pre-trained model that achieves state-of-the-art performance on two datasets in Vision, Language, and Navigation, VLN. In VLN, an agent is required to follow natural language instructions and navigate to a specific destination in an unseen house. Methods in this area build a joint representation of instructions and RGB panoramic observations by relying on data. But in the specific domain of indoor navigation, data is scarce, since obtaining many environments is hard. For example, how can we expect an agent to stop in front of the first Christmas tree when no Christmas tree was observed in the training set? As collecting more houses is hard, researchers have looked at alternatives such as conceptual caption, a large-scale automatically harvested image caption dataset. In this work, we argue that such pre-training is out of domain, because conceptual captions is composed of generic image caption pairs, whereas VLN tasks are composed of path in a house and navigation instructions. Pre-training enhances the correspondence between a visual and a textual representation of an object, but it is poorly improving the temporal reasoning required on long instructions. The main idea of our approach consists in collecting a large-scale in-domain dataset from rental marketplaces. B&B has considerably more environments than any other dataset and is related to houses and their descriptions, reducing the domain gap between pre-training and downstream tasks. But the domain gap remains important, since the B&B dataset is composed of image caption pairs, while the VLN tasks are composed of a pair with a path and an instruction. Can we reduce this domain gap even further? Our first naive approach consists in concatenating captions image pairs to create a new sample that looks like a path instruction pair. The instructions generated by concatenating images do not contain any of the actionable verbs as in navigation instructions. For example, turn left at the door or walk straight down the corridor. We suggest replacing noun phrases from VLN instructions with those from B&B captions. We also try to generate instructions out of a sequence of images by using a video captioning model. Moreover, each location only contains one B&B image and perhaps with a limited view angle, as hosts may focus on objects or amenities they wish to highlight. We showed that we can improve the impact of the pre-training by either grouping images from similar room categories or by inserting captionless images as if their caption was an empty string. For a fair comparison with VLN-BERT, we start with a VIL-BERT model pre-trained on conceptual caption, and we are going to fine-tune it on the same downstream task. But before fine-tuning, we pre-train VIL-BERT on the B&B dataset with 3 proxy tasks: word masking loss, image masking loss, and the shuffling loss. Another contribution of our paper consists in improving downstream fine-tuning by mining harder and more meaningful examples. We can adapt the shuffling loss used during pre-training by shuffling correct trajectories. This table shows that the introduced B&B dataset brings a 3.95% improvement, while the shuffling loss brings another 3.15% boost. Overall, we achieved a 9.41%. We used the same assembling model than VLN-BERT and achieved state-of-the-art performances on 2 VLN tasks: goal-oriented navigation, room-to-room, and object-oriented navigation, Reverie. Airbird can be readily integrated in discriminative and generative models for the above VLN tasks. When navigating in new environments, Airbird's model is able to recognize rare or even objects not seen in the training set. Thank you for watching this video. You can find additional examples on our website. Incorporating Airbird into your VLN model is very easy, and we make available code to download the B&B dataset and test our models.